podcast dedicated to hyperconvergence and virtualization. I have Mike Flender with me. Mike is a technical director, and now we refer to them as system architects here within the company. And so Mike is going to help us kind of wade through this topic of virtualization and more importantly, hyperconverged infrastructure. And before we get into hyperconverged infrastructure, Mike, maybe it'd be a good idea for us to kind of lay a base and talk a little bit about virtualization and how that's used in the systems and the servers that we sell to our customer base.
Absolutely. So virtualization allows you to take a computer hardware resource and abstract it to make it available for multiple operating systems to run on that hardware at the same time, allow you to maximize your investment in that hardware and maximize utilization of resources.
Okay, so kind of abstracting the hardware really means you're operating above that level and into these containers or buckets. Is that kind of what you're saying there, Mike?
Yeah, so you can take a server that has 8 cores and X amount of storage and memory, and you can carve that up so that you have multiple operating systems running at the same time on that hardware. One can have like 2 processors, cores. The other has 6 cores, and then a certain amount of that storage and so forth, allowing you to, once again, maximize your investment of that computer hardware.
So that does, Mike, that takes and really kind of makes it so you don't require a specific machine for a specific workload. You can divide a workload amongst divide workloads among one machine so that you can optimize your use of hardware. Is that correct, Mike?
Yeah. I mean, traditionally, in the older days, we would have a certain application running on a server, and that was the only thing that ran on that because you were worried that if you had a software error with that piece of hardware, it would impact the other application you're trying to run on that same piece of hardware. And so for uptime and stability, you would run one application or operating system on one piece of hardware. And we ended up with a lot of unused compute resources. And so virtualization helps solve that issue by allowing you to segregate your apps into different what are called virtual machines, running on their own operating system and so forth, and not interfering with each other, but running on the same piece of hardware, maximizing that hardware investment.
So, Mike, you just opened kind of an interesting question there. What allows a virtual machine to fail over? Now that you've got essentially multiple clients running on the machine, how does it resolve that uptime and reliability issue?
Yeah, so one thing people quickly realized is having multiple virtual machines running on one piece of hardware, that one piece of hardware becomes the single point of failure. And so there's this architecture that came about where you had a pool of storage that was shared between multiple servers, and you now did a cluster of servers running like VMware is a popular OS for this. And then because all of the virtual machines were running on that shared storage that all the servers had access to, you could have a server running a certain workload, and if that server failed, VMware would see that and automatically bring it up onto another piece of hardware that has not failed. And because the virtual machine is sitting on shared storage like a SAN, then all of a sudden, it's able to quickly see that and bring that up. And generally, this is done in milliseconds, and so normally the end user doesn't see any downtime. They might see a very brief blip, but typically they see no downtime.
Excellent. And so, if we were to try to summarize what the benefits of virtualization are, we could say that we're more effectively using the hardware by load balancing those applications on the hardware, but we're also providing the ability, to connect and essentially fail over in the event of a problem with one machine to another machine relatively quickly, so that the user does not have an interruption in what it is they're doing. Is that fair, Mike?
Absolutely. So now a hardware failure becomes a non-event and is seamlessly resolved by your architecture, so that you're still up and running in that event.
Okay, this is so good. I think we've got a baseline now for virtualization. Let's talk a little bit about a hyperconvergence system or a hyperconverged infrastructure. How is that used, and what is it good for in terms of our customer base? How are our customers using it?
Absolutely. So in our environments, we're always worried about size, weight, and power. And so hyperconvergence takes your shared pool of storage and integrates that into the server, your memory, your compute. Before you would have to have you'd have 3 nodes of servers, you'd have fiber channel switches connecting to a SAN, and then you'd have the SAN, and then you would also have networking, whereas hyperconverged infrastructure takes all of those individual pieces and integrates those into 3 servers or so, and basically abstracts that pool of storage. The networking and so forth has become software defined, and so you no longer need a separate network switch. You no longer need a SAN. You no longer need a fiber channel switch. Essentially, you're connected through a high-speed link through each of those 3 servers, and basically think of it as RAID 5 for storage, but at the server level. So you have abstracted the pool of resources to the point where you can lose an entire server and still be up and running. And then because of the not needing a SAN network switch and so forth, you're increasing swap.
Okay, so you're essentially sharing even more resources with hyperconverged infrastructure than you are with virtualization.
Yes.
Is that right? Yeah.
So you're simplifying the stack to 3 servers with increased storage and additional network ports, instead of having all of these individual items that increase the footprint of the architecture.
Okay, very good. Where is this technology going, and what do our customers find to be the most advantageous aspect of hyperconvergence?
Sure. So the nice thing about hyperconvergent infrastructure, it is easier for us to ruggedize 3 or more servers instead of 2 to 3 servers and a SAN and a network switch and so forth. So it's easier for the customer. It simplifies the customer's deployment and also administration and troubleshooting. It allows automatic failover of the virtual machines, as we talked about previously, between the multiple nodes that are clustered together in a hyperconverged infrastructure architecture. And then you're saving money on not buying fiber channel network switches. And then going forward, there are some new technologies that are coming about. For example, Kubernetes and Docker are software technologies that are bringing about what is called containerization. So a container is essentially a virtual machine without all the operating system cruft into it. It's the application and the bare resources that application needs to run virtualized. And then the advantage of that is you're now using less compute and less memory and less storage to deploy your application to the hyperconverged infrastructure. So that's kind of the future forward that is happening now, is people are moving from thick virtual machines to running containerized application on top of that.
So, Mike, if I understand this correctly, the thing with the containers is that it's stripping away some of the overhead associated with the OS, so you're not dealing with all of that necessary process, and you're just kind of getting down to the basics inside that container. Is that a fair assessment?
Absolutely. And then obviously one of the side benefits of that is you're not maintaining software security patches for that operating system and so forth, and having to implement security technical application or implementation guides for a operating system, you're generally just securing the application and not having to secure an operating system as well. So that helps on the administrative cybersecurity front for our customers as well.
Yeah, I remember a couple of our Air Force customers were pretty interested in rolling out essentially a configuration. They wanted to plug it in and just have the system configured automatically. Can you describe that a little bit on what the benefit to the user is with respect to that capability?
Yeah, so they were able to quickly and easily install, implement, and deploy the hyperconverged software on our hyperconverged hardware stack. And it simplified their administration and deployment, not just for them, but for their end customer with the Air Force and DoD as well. And it allowed them to guarantee uptime out in the field. They were in a forward deployed scenario where they didn't have a lot of IT people on hand. So it needed to be really a set it up in a transit case, plug it in, and connect a encrypted satellite uplink and be able to go.
Okay. And from the user standpoint, Mike, what does the management of a hyperconverged infrastructure look like? Is it a dashboard kind of thing, or what is it like?
Yeah, so for example, with VMware, they have VMware vCenter and vRealize operations software solutions that allow you to have essentially a single pane of glass for managing your infrastructure. Nutanix also provides a similar single pane of glass for managing and configuring and monitoring your hyperconverged stack. Also, I believe their solution is called Prism for the single pane of glass, and it's really allows the admin to just at a glance see how things are running, see if there's any issues, and they can even tune resources if they see moving a certain virtual machine or container to a different member of the cluster will improve performance. They can easily see that and do that.
Yeah, one of the features of hyperconvergence is it does you can set it to automatically balance.
Yes.
Is that true, Mike?
Yeah, so automatic load balancing and setting prioritization for different virtual machines or containers really helps automate that process so that you don't have to be hands-on with it, and it'll automatically tune itself as workloads change.
All right. Well, Mike, I've been asking you a bunch of questions here. What question do you wish I would have asked that I didn't?
That is a great question. I would just state that, Crystal has a long history of providing hyperconverged and virtualized infrastructure to its clients, and more importantly, they are doing it in a manner that will meet, mil standard 810 shock and vibration thermal requirements that exceed what your traditional commercial vendors can support. We can make sure that it withstands humidity. We can, vibration. We can do certain EMI hardening requirements. There's just so many things that we can do that maximize this technology for the DoD that really makes it a differentiator for them.
Great. Well, it looks like, Mike, that at least in my opinion, it looks like hyperconvergence is here to stay. It's gaining more and more traction, and it's going to be something that we'll be dealing with for quite some time. So I'd like to thank you for spending a little bit of time with us and enlightening us on how hyperconvergence works, how virtualization works, and just thank you very much.
My pleasure. I'd encourage people that hear this to reach out to us and talk to us about how we can help them with this.
It's very easy to reach out to us at crystalrugged.com and just drop us a line there. We would love to respond to any questions you might have or any concerns. Have a great day. Thank you.
Thank you.